Hi everyone, I am Abbas Maske and currently the project manager for BIRDS-3. I'm from Nepal and my major role here in the project is to create an environment for all the members of BIRDS-3 so that they can work in harmony and also work in the same wavelength. Major work specifically on the system is on camera and also the backplane design. This role actually started changing from BIRDS-2 and since then the project manager also has been involved in the hands-on process. So as you can see here, we have a couple of PCBs. These are all that I've worked on. This specifically is for the BBM called breadboard model, but the BBM itself has been made on the PCB. This is the microcontroller, the flash memory, and the camera would basically fit in here. This board would then be placed on a test bed, and then we can actually make it work. From BBM, we move on to the stage called EM, engineering model. As you can see, two missions, camera missions and ADCS missions, have been placed together. You have the camera here, the processor, flash memory, the ADCS processor, GPS, all have been placed on the same PCB, right? I've also been working with Turo from Mongolia, and this is his research. It's called a soft CIB. It's a backplane, but you can define the connections through the CPLD, right? So basically, you can change the connections as you wish using this CPLD here. This board will only be used for the Japanese mission, but for the Sri Lankan and Nepalese satellites, we'll be using a hardwired backplane. So you can see there's no CPLD in this board. And the reason is that we want to reduce risk. If we use this board, which has never been used before, we are not sure whether there will be a problem or not. So in order to reduce risk on both Nepali and the Sri Lankan satellites, we're going to use this CPLD.
Hello, I am Puja Lepta and I am from Bhutan. I am taking care of EPS in BIRDS-3. EPS comprises of solar panels and batteries, and EPS is mainly responsible for providing uninterrupted power supply to the CubeSat in sunlight and in eclipse. This is the engineering model of BIRDS-3 Cube satellite. We have solar panels on 5 sides of the CubeSat, and on one side we have the antenna. We have a battery box like this inside the CubeSat. We have 6 batteries, out of which 3 are connected in series and 2 packs connected in parallel. The average power generation on orbit is around 1.2 watt hour, and during missions the total power consumption of by the satellite is around 1.1 watt hour. I'm also looking after the fab board. This is the fab board. This one has the ADC converters, and this one receives the data from solar panels. It receives the voltage generated from the solar panels, the current, and also the temperature of each of the solar panels. So we know how much is the temperature on orbit. The data that is collected by FAB is then sent to OBC, the main PIC, and the main PIC will send the data as in the form of housekeeping data and also in CW. Right now I'm trying to get some sensor data from the FAB PIC, and Being a part of BIRDS-3 has been a really interesting and a learning experience for me. I have come to learn a lot of things that I didn't know before, and I would like to thank QTech and all my team members for this opportunity. Thank you.
I'm Dulani from Sri Lanka. I'm doing the ADCS subsystem in BIRDS-3 CubeSat, and in BIRDS-2 and BIRDS-1 they had a passive attitude control, which where they used a hysteresis damper and a magnet. But this time we are trying to stabilize the satellite using 3 magnetic tokens. Through this BIRDS-3 project, I'm learning a lot about the space engineering and even the electronics and even the programming. And actually, it's a very nice thing to work with these kind of the BIRDS-3 team members, because they are very helpful and they are from different countries. Actually, there are people from 4 countries working here, and studying about space engineering was a dream, and then actually now I'm studying about that, so I'm very happy about that. And I hope that BIRDS-3 satellite will be successful and we will get the correct data when it is in the orbit. Thank you.
I am Sarindu Dayaratne from Sri Lanka. So my part in BIRDS-3 is communication subsystem. So it's a very important subsystem, and if communication subsystem fails, satellite fails. So if you come closer and see here, you can see here is the communication board. So now I can't show the communication board. Reason is we have assembled the satellite for testing. I'll explain what is that test. So then this is the coaxial cable. This is the cable we use to send and receive RF signal. So this communication board is connected to communication microcontroller. So if I show this one, and if you come close and see here communication microcontroller, this one is connected to this transceiver board, and if this one receive a command or signal, it directly transfer this one to here. At the communication peak, it analyze the signal and not actually signal, it's a command, it's a digital data. So according to that digital data, it do the things it related. And right now what I am doing is, when I testing this engineering model, so I noticed some issues. So it was something like error in the received data. So what I'm now going to do is, I created a function to correct that error. So I'm going to upload that data into that code into the communication peak, and then check whether that code is working. So right now I have uploaded code. Before this video I uploaded the code. Now I'm going to turn on the satellite and send a signal from ground station to the satellite. Before that one, we have to connect a attenuator for this coaxial cable. Reason is, sometimes we are transmitting signal from the satellite. It's a very powerful signal. If it is leaked to the outside, it's a interference to the other, let's say amateur guys, they will complain us, we are transmitting unwanted signal. So that one, because of that, we have to connect attenuators. So what I'm going to do right now is, we are going to connect attenuator. I'm going to connect attenuator. So then I connect the antenna for this coaxial cable. This is the monopole antenna. Actually, this is the not this antenna is just a normal monopole antenna. So for testing, we are using this one. For actual case, this is the monopole we are going to use, but we are using this one for the testing. So then we will transmit the signal and check whether it has still error. So actually this is very interesting. For me, this is very interesting. So I face a lot of problem. So lot of problem I solve. When I solve a problem, I can learn something. So I think my final aim of this project is learning something and making the satellite for the country. So as my opinion, personal opinion, it's a very good project to learn something and do something for the country. So as a team, we are working hard right now. So I hope it will be successful, and thank you.
Okay, hello, my name is Yuta Kakimoto, and I am from Japan, and my BIRDS-3 back part is onboard computer, OBC, and thermal analysis. And I also support for the ADCS mission for training. And this is the OBC board which I use. So now I program to this microprocessor PIC 18F. Now I'm writing some software into this processor. I have to communicate with most of other subsystems. So I will use many UART communication. So I need to think about the mission flow, OBC flow properly. So that's a hard part. And also, I need to store many data to some flash memory. So I also need to think about which data, how frequently store to the flash memory. I also have to think about. And this is a serial monitor from the main peak, my OBC peak. I get some data from this peak to PC and monitor it work properly. And now this is some data from front access board. Front access board get some sensor data, many sensor data, outside panel, power data, current data, voltage data, or temperature data, or some other subsystems, board data, board temperature data, or power data. So here I check the hex value and calibrate to actual temperature data or voltage data, current data. Okay, so this is my thermal analysis part. And this is a BIRDS-3 thermal analysis model. I use the thermal desktop as a software. And this is a 3D CAD model, make the 3D CAD model right there. This is the outside. And inside is like that. I make like that simple model and analyze like that. So from now, I need to improve this model for some condition. So now I have many work on OBC or thermal analysis or ADCS support, but this is a very good for my improving my skill. So I'm very happy to join this project. Thank you.
My name is Makiko Kishimoto. I'm from Japan. My part of BIRDS-3 project is ground station and antenna design and deployment system. First, I explain about ground station. When we operate with satellite, we use radio and TNC and antenna, and also use laptop. Radio and TNC connect with laptop, and this software, operation software, will control the radio and TNC. This software is developed by BIRDS-1 and BIRDS-2. Here is a main screen, and also has a command uplink, and here is telemetry, camera mission, and other mission, and here can receive the data from satellite. So, and also I developing the new software for future BIRDS project mission. So includes BIRDS-3 and BIRDS-4 and BIRDS-5. Okay, next I explain about antenna. So this one is the minus X panel of BIRDS-3 satellite. Here is the main antenna, main monopole antenna. Receives the command from ground station and sends the data to ground station. And also has a GPS patch antenna. Then, before release from ISS, I tie the antenna like this and turn on the banner circuit to deploy antenna. So after that, antenna deployment like this. Okay. So I feel happy can join the BIRDS-3 project. So because I can learn many things from the BIRDS-3 members, so I want to do my best for success of BIRDS-3 project. Thank you.
Hello, I'm Yuji Sasaki. I'm from Japan. My part in BIRDS-3 project is structure design and analysis and crew mission. This structure is inherited from BIRDS-1 and BIRDS-2's structure design. However, minor changes were made to the design of structure to improve the ease of assembly. I am also devising the measures to reduce the overall manufacturing cost by making simpler designs. I have made the satellite models using 3D CAD software, incorporating the exact shape and size of the component. In this way, I know the exact space between them. This also helps while making changes in the components, since I would know if the component will create any problem in the real structure. When the satellite structure arrives, I assemble them and check if there is a problem. I was very nervous about the CAD model of the satellite conforming with actual satellite structure. Fortunately, The satellite structure assembles perfectly and on the schedule, and it was possible to have a thermal vacuum test and vibration test on the target date. I am disassembling the engineering model of the satellite in this video after thermal vacuum test. After confirming that the EM model has no problem with all the tests, I will then move to the design of flight model. I'm very happy because I'm part of BIRDS-3 member. I learned many things. Thank you.